Welcome everybody to, like I was saying earlier when we were chatting, the first webinar meetup that we've ever held as part of the SV Hardware Development Product Meetup, and this topic is on Agile hardware product realization. I'm very excited to have Bernie and Jay join me as expert speakers, and we're going to be talking about how to lower risk, reduce costs, meet deadlines by leveraging Agile hardware product realization practices versus Agile software product realization practices. So if you want to advance the slide, there we go. All right. Quick introduction of myself. My name is Michael Kier. I've been in the thick of hardware product development for over 30 years now. And I worked at OEMs, I worked at CMs, I've seen a lot of over 100 products through the product development process. And back in 2010, founded Product Realization Group to help companies better navigate that transition. I'm actively a mentor primarily in the clean tech area right now and ocean tech area, and have a background in industrial and a master's in manufacturing engineering. So with that, I'm going to let Bernie introduce himself, and then we'll move on to Jay. So Bernie.
Hi, everybody. My name is Bernie Maloney. So I'm an Agile coach and trainer these days, but I really got my start in Agile about 25 years ago in a division at HP where we were building consumer PCs. Now, if you remember back that far, consumer PCs had sheet metal in them. And since this is a hardware meetup, you pretty well know that that's about a 14-month lead time. Motherboards, they're about a 9-month lead time, but the shelf life of a consumer PC is only about 3 months because Intel changes their roadmap every 3 months. Wait, it gets even more fun. So not only did we have tight deadlines like that, we had high complexity. So when I was there, we started shipping 6 products a quarter when I showed up, 20 in the US. Pretty soon, by the time I left, after a few years, it was 200 different products every quarter in Europe alone. We did it with distributed teams where we had engineering in Silicon Valley, we had volume manufacturing in Asia, and we had go-to-market in Grenoble, France. We did it with razor-thin margins, okay? And we did it with weekly iterations of a plan. While I was there, the business grew from break even to $1 billion a quarter. So I've done high volume distributed teams, low margin. Ooh, our margins on a good day were 8% gross margin. Okay. Those Black Friday SKUs we all like buying, 2% gross margins. Okay, with really tight deadlines. We never missed a ship date in the 8 years that I was there. So I'm a stone cold believer in anything that I teach about Agile these days. That's a little bit about my background. Jay, I think you
good. Thank you, Bernie. And Jay, you want to continue?
Hi, my name is Jay Feldis. My background is electrical engineering. I've had 35 years in hardware product development. I spent 13 years at Logitech, putting the webcam product line on the map. We developed, starting at the beginning, 1 product, but eventually grew that to where we were putting out 6 cameras a year. And in that business, the consumer hardware business, pretty much you have to have your product going on the shelf for Christmas, which means, if you're not shipping by September, you're pretty much dead and you kind of wasted your time for the past year. So it was extremely important that whatever we were building, that we delivered it on schedule. And so you learn a lot about how to adapt and keep things moving, but not losing your schedule, because that's paramount. So in addition to that, I've worked in a couple of startups, and I've been working with PRG for over 6 years, helping companies do their project planning, their engineering management, planning out their product development in the stages up through reaching manufacturing.
All right, thank you, Jay. Want to hit the next slide? All right, a little bit about Product Realization Group. I mentioned I've been in this industry for over 30 years, and when I was working at contract manufacturer, I saw a lot of our clients struggling. This is some years ago, and in 2010 started the group to help companies bridge the chasm between prototype and full-scale manufacturing. So that was really the original intent. We are mission driven, really working to focus on companies that are building a sustainable future, and we support a wide variety of companies that are developing physical products, from startups to Fortune 500. So with that, go ahead and do the next. All right, so this topic today is around agile hardware new product development, but over the years, we've created what we call 10 best practices to help companies better navigate this chasm between prototype and scale. We're not going to go through those, but I just want to, kind of increase awareness that there is a lot of complexity. Hardware is hard, and there are best practices around how to make that navigation more smooth, more smooth for companies. And if you follow these 10 best practices, you'll have a much better chance of getting a good product to market. Yeah. So next. So what happens if you don't follow the best practices? And that's what this graph is showing here. So if you look at it, call this the hardware conundrum, right? You start and you stay lean early, you underinvest, you don't do the right things at the right time. And companies that follow these call them bad practices will invariably miss their launch date, and then do a mad scramble, which is that line going down, to get products in a form that they can actually ship. And by the time they do ship, they're late, they're over budget, and they're not meeting the intended requirements. So and by following this process, you really limit your profitability. And if you go to the next slide, you can see what following the best practices does look like. So if you do, if you do follow the best practices, you can see you may invest a little bit more upfront, but your total investment is actually going to be lower. You are going to meet the intended product requirements. You're going to ship on time, and you're going to have the ability to make extra profits over the longer term, and sustain the product life cycle over a longer period of time by following these best practices. So. So with that, let's jump into the meat of the presentation. I'm going to go ahead and turn it back to Bernie, who is the expert on Agile, and go ahead, Bernie, talk about this stuff. Yeah.
Terrific. So since I don't know what the background is of pretty much everybody in the audience, I'm going to do a little bit of framing here. So lots of folks are used to waterfall development, which works in a plan and predict world. It's great where your market's not moving fast, or your technology is not moving fast. Okay, but one of the things I regularly ask my clients, my students, is, hey, the market that you're serving, is it moving faster or slower than it was, say, 5 or 10 years ago? Most people say faster. Great. How about the technology? Faster or slower than 5 or 10 years ago? Most people say faster. Hey, when things are moving faster, are they always moving in a straight line? No, they agree with that. Yet, a lot of organizations still live in a plan and predict world, which really only works when you're kind of close to those knowns and things are moving in a straight line. That's where Agile comes in. It really grew up in a software development space, but here's an interesting thing. It was originally, some of the roots of it were really in product development, not necessarily software development. And the whole idea about Agile is it's essentially empiricism, the experimental method. You do a sense and respond rather than a plan and predict. And you tend to operate in cycles where you make an experiment, a hypothesis, and then you go run an iteration. And think of this as developing an MVP, or in hardware terms, maybe it's your P0 or your EVD prototype. Okay, and then you move forward and you iterate a little bit more and a little bit more until you get to a final product. Next slide, if you would, please. So a big thing about Agile, oh my gosh, it went black. And then it went to title slide. It didn't go to the slide that I expected. There, that's the one that I was expecting. Okay, so this is something that I like to use to explain Agile. Okay, it's the Mobius framework from a trainer based out of the UK. Her name is Gabby Benefield. I think it's absolutely brilliant. There's a link to her website down in the bottom right-hand corner of this slide. So everybody gets the whole idea of a Mobius loop in general. It's this infinite loop of back and forth and back and forth. Most people think of Agile as only the right-hand half of this loop. And they think of it like in Eric Rie's terms, build, measure, learn, build, measure, learn. And you'll hear some Agilists call that the build trap. That right-hand half is all about the delivery of a solution. The left-hand half is a really important part of Agile that gets overlooked by most folks. Okay, it's all about the discovery of the problem and who to solve it for. So really, the whole idea of Agile is to do both discovery and delivery. The right-hand half is all about exploiting a known idea, and the left-hand half of this is all about exploring the idea and figuring it out and starting to squeeze risk out of the system. That's a big part of what you're doing as you kind of flow across this. Next slide, if you would, please. Now, what a lot of organizations do when they, wow, okay, cool, we're bouncing all around. We'll get to that slide. There it is. Okay, when an organization sets a target out there, way out on the right in time, what a lot of them do, I'm just going to do a quick annotate here. They only think of things in terms of what they're aiming at. And that's kind of a mistake. A lot of organizations go through just by planning and predicting. The future is going to be very much like the past. But one of the things in that division at HP that we knew, with a market that was moving that fast, we had to have a greater range of things that we put into the early part of the pipeline as we started to explore some of the early stuff that we did. Now, we didn't use the language of EVT, DVT, PVT, or P0, P1, P2. We talked about it in terms of kind of stage gates. And what you're doing over time is you're actually running those experiments. You're figuring out what's possible and what the market's going to tolerate. And over time, okay, you're going to find out it's no longer needed in the market, or we're not going to be able to deliver it. And you're starting to winnow things down as you go forward. Now, another important thing to think about when you're aiming this funnel, because you want to start a whole bunch of experiments to begin with to prove out things, is you got to recognize the market can kind of shift on you. Next slide, if you would, please. And one of the things that happens is instead of aiming straight forward, okay, you got to recognize the market is going to shift over time. So you want to start that initial funnel out really wide, because if the market shifts on you, like the things that I've drawn in over the top, ooh, you've got kind of a left turn at Albuquerque that you've got to go through. And then if the market shifts again, you got a right turn at Albuquerque. It can be really painful. So instead, by starting out with a wider set of things to experiment when you're starting a design cycle and winnowing it down over time, you're going to mitigate some of the risk. Okay, so, and you're going to be going back and forth. That's the little Mobius loop that you see in there between the whole discovery and delivery. Now, what this does is it sets you up with those typical stage gates that you experience in hardware, whether you call them EVT, PVT, or DVT, and you're running experiments to start to winnow this out. If you would, next slide. And Jay, I think
Yes,
you're going to speak to this one.
I will. We get to it.
Ooh,
There it is. All right. So what we have here is kind of a traditional stage gate process, which you may have seen. And so, as you go from left to right, it's, what's happening also here is that funnel we saw before is happening. But you see in between these gates, you see we've got our Agile loops. And the idea here is that the stage gates give you kind of a structure to make sure that you're making important decisions at the right time, so that you can assure that you're going to meet your deadline. So many of the things in hardware that come up is some extremely long lead times. So maybe you're making tooling, which takes 12 or 16 weeks, or maybe you have to buy parts that are taking 26 or 52 weeks to get. And so when you're making your project plan, you need to make sure that you understand those general lead times so that you can plan when you have to make that cutoff decision. Okay, we got to do tooling by a certain time. We've got to order these parts by a certain time. We've got to make certain feature decisions by a certain time. So the way you're funneling down as you go is by making sure that each of these gates, you've got a checklist of what you need to accomplish. You cannot pass that gate until you've achieved that. So your loops have to really be focused on, what do I got to do to meet the gates at the times I have in my plan? And obviously, if you're in your early stage, you've got a lot more flexibility to change and experiment. But as you go, decisions are getting made. Okay, we've decided on the tooling. It's got to fit in this form factor. We've decided on the processor. We've got to use that processor now because it's got a long lead, and so on and so forth as we go through. So I think it's a matter of combining those two, but it's really important that you plan out when you're going to do these things and you've thought about the risk. You're saying, well, where are my biggest risk items? I got to solve that early in this process. Where are my biggest long leads? I've got to make sure I solve those early so that, by the time we get late in the process, we're handling kind of the more flexible stuff and the short-term stuff.
Amen, Jay.
Yeah. Excellent. Yeah, the only other thing I would add is these cycles are likely not going to be 2-week software sprints. They're going to be dependent on the kind of hardware complexity that you're dealing with. So they could be shorter, they could be longer, but you can't test hardware unless you have it all the way built up.
Correct. Indeed, it does depend what it is, and I think looking at fast turn, whether it's 3D printing or fast turn boards, I mean, you may want to spend a lot of money to have a board made in a week because it's going to keep you on schedule and keep you from being late.
Yeah.
So this is all things to be thought about.
Yeah. Now I'm going to inject something here, Mike.
Yeah.
Okay. Yes and no. Okay. So yes and no, because when in that division at HP I talked about, we would run weekly iterations of a plan. So you may not actually rev the hardware, but the plan for what you're going to be doing in volume itself is software. So a key in hardware is you want to start abstracting the plan.
Exactly.
Okay. And when you start to look at like what that go-to-market is like, that you can iterate on a weekly basis, which is what we did. And that informed our decisions as we started to narrow that funnel as we went through each of these approvals.
And I think you're getting at a little bit of the, kind of the nut of what are some of the differences between Agile software versus Agile hardware. Yeah. Yes, you can iterate on the plan, but the hardware is still going to take what it takes in order to be able to actually test it.
Yeah.
Another way of thinking about it, leave this slide up here for a second, that I liken with my clients is, I'll ask them, hey, so do you think startups, are they Agile or are they waterfall? Lots of people think Agile, of course. And then I ask them, have you ever heard of venture capitalists? Well, yeah. Have you ever heard of funding rounds? Well, maybe not. You explain funding rounds to them and I go, well, so what are funding rounds with venture capitalists? They're stage gates. So here's the thing, even about software startups, those funding rounds are funding to explore an idea and get to the next gate. To look at the overall market, which is software, okay, about how the market's behaving, to know what you're going to launch into the market eventually. So the same concepts apply, whether you're in software or hardware. Honestly, the software people are a little bit far behind. Even 5 or 6 years ago at high levels in the Agile community, people were like, oh, you can't do this stuff in hardware. And I'm thinking, I did 20 years ago at that point.
We just didn't call it that.
I think that's the
Yeah, we
benefit
didn't call it that,
of this kind of presentation is to share, these concepts actually have been active in hardware for a long time. But the buzz has been around software because that's been where a lot of the, investment has gone and a lot of the resources have gone. But, there's still a lot of tools in the toolkit for hardware that are out there that people have been using a long time that really do, help you accelerate the development process. Okay, well, fantastic. Anything else on this slide, Jay or Bernie? If not, I think we'll go ahead and go into the Q&A section. And again, I'll put it out for the audience. If you have any questions, please add them to the Q&A chat box. And what we'll do is why don't we start with there is a question from, hopefully I get the pronunciation right, Paul Benick. Lower risk and agile development, does this mean less documentation? Okay, so does that make sense, Jay and Bernie?
Yeah, I can jump on.
Yeah, why don't you take it, Bernie? Your eyes.
I've been talking a lot, Jay. I want to give Jay a chance to okay.
I mean, well, my answer is no. I mean, it means putting processes in so that you're collecting your documentation, because on a piece of hardware, if you haven't documented what it is, if you don't have the drawings or the specs or the bill of materials, you're probably going to get lost down the road. So If that's what you mean, no, you need that. It's just you've got to be using tools that let you collect that data as you go, not make it as a secondary, and after the fact.
So I'm a good consultant, y'all, So a lot of my answers are, it depends. So Jay,
Of course.
I'm a yes and, okay.
Yes.
I'm a yes and on this one. So, okay, the Agile Manifesto for software development. One of the things I'll tell folks is you can ignore the word software, just put the word product in there. It works really well. You don't need to hire a fancy consultant who does it like for marketing, for HR, for hardware, okay? Anywhere it says software in the manifesto or principles, just substitute the word product. It works super well. There's 4 values in the manifesto, okay? And one of them is customer collaboration over comprehensive documentation, which leads to people thinking, oh, we don't have to document anything. Usually it's the coders in software that's we're Agile, we don't have to document anything. And that's where I like to say it's, it's not no documentation, okay? It's low documentation. So early on, you want to get just enough information so that you can build something and then go run an experiment and then document the outcome of that. So as you get closer and closer to actually putting it into play, that's where you want to increase the quality of your documentation. But early on, yeah, you can go with low, but I would not say no documentation. And then as you get closer and closer to that release, you want to have higher and higher quality documentation, kind of like Jace was talking about.
I agree. I agree with that. I think, yes, in your early prototype stage, if it's just, one engineer working, on the workbench and building parts, okay, maybe a lab notebook will do it. I think the key is that if you need to hand this off to someone, that's where you need it. So if you're handing something off to a manufacturer, that's where the rubber hits the road, because if you haven't specified a tolerance or a length or a material or anything like that, you might get what you think you're getting, or you might get something that they picked, that isn't exactly quite what you thought.
Yeah.
And so I've seen that happen many times, that manufacturers are building something different than the engineers thought they designed because they didn't specify it.
And I'm right there with you, Jay.
Yeah.
Something I recognize I failed to put into my own bio when I introduced myself. Y'all, I'm a mechanical engineer by training. I'm actually licensed in the state of California, M29407, if you want to look me up. Okay, so that is my background, and that's kind of the background that I bring to this. I'm not a dyed-in-the-wool software person.
The other concept I would add to the discussion is, from my experience, is the idea of as you go down the development chain, you need more control. So if you're in a lab and you're developing and you're playing, hey, have at it. But once you get to a point where as Jay said, you've got to hand that information off to, let's say, an external manufacturer or development partner. You better have your documentation kind of lined up and ready to go, or it's going to be very hard to figure out what's going on there.
I want to tweak one word in what you said, Mike.
Sure.
So I get the intent behind you want to have more control. I would actually phrase it as you want to have more certainty. Okay. So the closer and closer you get to release, the more certainty that you want to have. And yeah, it may not necessarily be control, but certainty, and like Jay was talking about, the tolerances that you can handle there.
Yeah, and maybe it's just semantics, but I'm an operations guy by training. You better be able to control stuff when you're manufacturing in volume, or you're going to run into trouble.
I completely, as you're getting there, yeah, you want to have those manufacturing limits. Absolutely.
Yeah. All right. Well, very good. Well, thank you for that. Yeah, hopefully that answered the question. I am going to put a reminder, if anybody does have questions, please add them to the Q&A part of the chat, and we will be more than happy to address them. And I'm going to move on to the next question. This question I'm going to lead off with Bernie. And the question is, how do I iterate quickly with the inherent latency of developing hardware products versus software products?
Cool. Okay, so we've touched on this a little bit, but let me unpack it. Think back to that slide where we showed some of the stage gates. Okay, those stage gates are they're going to fix the hardware platform that you're going to be able to work with. Now, within those stage gates, you can run lots of experiments. So as you're designing that pipeline, that funnel, you want to be designing each of those like EVT, PVT, DVT platforms, or P0, P1, P2, to have the greatest range of possibility for the experiments that you can run. If you need to iterate more quickly, one of the things Jay's already referenced is like you might want to go to soft tooling. So you might want to pay for some quick turns to get something run down. Here's a big thing that goes on with Agile. You got to help an organization get out of a plan and predict mentality, a one and done mentality. And you've got to recognize that there's going to be rework. Okay, there's going to be rework, and it's okay, because what you're doing with that rework is you're squeezing uncertainty out of the system. You're starting to get closer to that control, Michael, that you can manufacture in volume with good quality. So the way to iterate quickly is plan ahead. Something that I always talk about in software is 3 sprints ahead, which is at maximum in Scrum 3 months. But hardware cycles have longer than that. Like at HP, our release cycle was 3 months. We'd look 9 months ahead, 3 complete release cycles. When you're looking 3 release cycles ahead, it's kind of like surfing waves. Surfers look at sets of waves. They actually look at them in sets of 4. And they're looking out beyond the horizon to what might be coming in to start planning their next move. And that's a big thing that you need to do in hardware, is kind of anticipate where that market, where the hardware is going to be, and aim for that versus just going straight ahead and being constrained into the only thing that you've got there. Jay.
Yeah, very good.
Yeah,
Jay, any other thoughts?
Yeah.
Jay?
I could add a little bit. I agree all across the board there. I think one other technique that I've used is if you're, say, at a stage in the product where suddenly the deadline is looming, the lead time is really long, but you're not sure, is it going to be chip A or chip B, or version A or version B? In a hardware project, you've got you've got degrees of freedom. You've got the cost, you've got the schedule, and you've got the performance, right? And if you're coming up a deadline and you're saying, okay, if I don't make this decision now, I'm going to be late. I'm going to lose my schedule. My schedule is paramount. Well, look at the other 2 sides of that triangle. What can you do? You can either find a way to spend more money to keep yourself on schedule, or you can maybe trim features from your product because, I'd rather have an MVP that does a little less and still on time, right? But one thing you can do on the cost side is, you start making risk buys. You say, well, it's 80% certain we'll use this part. We'll buy it. Yeah, there's a chance we're going to scrap them, but so be it. Or else maybe I've seen people go forward with 2 versions of a design. Well, we're not sure which chip is better. Let's prototype both of them in parallel.
Absolutely.
And yeah, that's going to double our cost, but we'll be able to pick one of those by our deadline and keep on schedule, right? So you've traded money for time.
Absolutely. I can even tell the story about the weekend I blew $1 million of HP money, okay, in making one of those risk buys, Jay.
Yeah.
I was forgiven. I wasn't fired because everybody recognized there was going to be rework.
Oh, I used to have bosses come out, my VP would come after me and say, how come you haven't spent enough? Because you're probably being
that sounds like a good story, Bernie. You want to share that?
Sure. So just like Jay outlined, this was one of those situations where we were kind of looking at the market. At this point in time, remember, this is back about 25 years ago. HP consumer PCs were entering the Nordic markets, and the Nordics behaved a little bit differently. They wanted lots of bells and whistles, and I can't remember what bell or whistle they wanted. Let's call it Bluetooth. Okay, they were really big on Bluetooth, but I don't remember if that was the feature. In order for us to make our production timeline to be able to release, like Jay said, I mean, consumer products, you got to be shipping by September if you're going to be selling by Christmas. So hard deadlines, hard windows. To be able to do that, we would have to make a component buy. It was Friday. There was nobody higher up than me in the organization. I had 0 direct reports, y'all. Okay, even though I was responsible for the $1 billion a quarter product line. That was kind of the way that it worked. So it fell to me to make the call. That was my role. and knowing how important it was to the business is like, go make the component buy. And I did it knowing full well from our procurement people that if we made the wrong call and we found out new information on Monday, to sell it back to the vendor, we'd have to take $1 million loss. I made the call. Now, after that happened, okay, there's a practice in Agile that's called a retrospective. You don't call it a postmortem because nothing's dead, okay? You're just looking back. If you're familiar with the military has after action reports. So we did a debrief on what this, it was not a comfortable conversation. But one of the beautiful things about that division was they recognized this was a razor thin margin business, like I already outlined for you, and mistakes would be made. So when they founded the division, one ethic that they established was make new mistakes, which sent a psychological safety. And that's really key for high performing teams. And Agilists talk about it all the time. A psychological safety message into the organization that mistakes would be forgiven if they were honest one time. Okay, don't make the same mistake twice. So we had that debrief, and the conversation at the end of it, after we like unpacked all of it, was like, well, from the division manager, let's make new mistakes the next time. Okay, so yeah, it happens. You'd have to make those risk buys to preserve some of that optionality.
Yeah, that's great, great story. And I've been told that Apple actually does 3 full iterations of any product, and then they pick the best one, and that's what they go to volume with. So if you have endless supplies of money, there's all sorts of things you can do. But unfortunately, not all companies have that luxury. So
yeah,
all right. Well,
let me just inject a big shift for success in Agile is to get out of a mindset of plan and predict and get into a mindset of sense and respond. Get out of a mindset of one and done and get into a mindset of we're going to have to run experiments and there will be rework.
Absolutely. Good point. So I've got another one. It's a little bit long. I'm going to see if I can get through it. And I think I understand the intent. This is from Cam. Question is, what is the difference in the tools and techniques for Agile when it comes to product scheduling for development? And then I think the rest is a note. If you are always sensing the system, how far out is the outcome of timing for network iterations and stage gates for the run experiments for when you're scheduling, I guess. Yeah. Does that make sense? Does that?
Mike, I can talk to anything, but I've been talking an awful lot. I want to make room for Jay.
We go back and forth.
Why don't you take? I think this is more your at least to start with, Bernie. Yeah. So.
Okay. Difference in tools and techniques. Product scheduling for development. Okay, so it depends on what product scheduling means here. If you're meaning for production scheduling, in an environment like Jay and I have talked about, consumer products have hard deadlines because the consumer market moves in 3 or 4, depending on how you look at it, phases in an annual basis. And depending on the product, like TVs are on an annual product cycle. Another product that I did with hardware development at HP. Yeah, I actually shipped an internet connected TV from HP. That's another story. So those manufacturing deadlines, those are hard deadlines. You've got to be ready for it. There's a principle out of Lean, and the software people love to talk about Lean software development, but it actually comes out of manufacturing, y'all. The folks who brought Lean into software were factory floor automation engineers, Tom and Mary Poppendike. And one of the principles is a last responsible moment decision. So like I talked about with that division at HP, sheet metal has about a 14-month lead time. At 14 months before we needed to be in retail, we would make the best decision we could with the information we had. But the range of capabilities of that hardware would be wider than we knew the market would need to be. Okay, so you don't optimize for cost, you optimize for later decision makings in something like that.
Yeah.
So so the tools and techniques, you're still going to plan out, okay, for production, but it's like you want to optimize for change is a big thing that you want to do. Jay?
I think getting more specific into tools, I think sometimes people are like, well, do you use Jira or do you use Do you use a waterfall, a multi-step project or something? And I think, what I like to do is I will kind of blend that. I mean, I like to build a good old fashioned, project plan kind of, in the waterfall style, specifically so that I can link together my dependencies, so that I can find what is my critical path. So that would go into there would be my manufacturing ramp up times, my materials procurement times, my estimated test times, and so on. And you can start to find out what's the most longest leg in your system. And you'd want to then attack those as your high risk areas, right? You want to use that to find it and shorten those. But then between those gates, once you have that kind of grand plan laid out, that's where you want to put your agile loops. And you just make sure you stay within your hard deadlines that you've got on your long-term, project milestone schedule. You want to say, well, I've got a deadline here for this decision. I can loop all I want until I get there. Then I have to decide, right? So it's kind of a blend of those two things. And whatever tool you're using, whether it's a Jira for managing problems, that's fine. But don't lose track of prioritizing what you've got to work on at this time period to reduce your risk and handle your lead time issues.
Okay, so I got to inject something here about Jira, y'all.
Yeah.
If you're ever exposed to Jira, Jira was originally designed as a bug tracker, which is why it behaves the way it is. And Jira is really prevalent in Agile because it is the lowest cost to license tool. And usually the organization making the buying decision is seen as the cost center. So for that work that we did at HP 25 years ago, didn't have Jira, didn't have any tools like this. We ran that entire business off of Excel spreadsheets, PowerPoint decks, okay, and Microsoft Project. So yeah, Jay, same thing. Know where those decision points are, and a project plan is great for that. Okay, project plan is great for that. But then the soft iterations that we do for what the plan was were in PowerPoint decks. And then that would cascade into, okay, so the way that we talked about it is if the plane crashed, okay, today, or if everybody died, in some fashion, what would the product be? And we would capture that in an Excel spreadsheet. And that was the marching orders. And so our manufacturing teams would be looking at that on a weekly basis to look for any tweaks or changes to be sure that they were there. So you don't have to have a whole bunch of complex tools to be able to do this. And like our communication tools were net meeting. It was pre-Zoom. So
I think the tendency I see is that what tends not to work well is just creating a giant backlog of bugs that kind of arbitrarily work through. That may get you in trouble. It's really, really important that whatever the bugs or the problems are, that they're prioritized and sorted within the context of those big milestones you need to meet.
Yeah.
So
okay, I want to get a little geeky on the Agile side here. So backlogs, there's both product backlogs that are the whole product. There's sprint backlogs on what you're doing in just a short iteration. Okay, so that's one distinction that I find folks new to Agile fail to make. Another key distinction is product backlogs should always have a product goal. It serves as a guiding principle for what should be going into this product, okay, versus not, okay? If it doesn't fit with the product goal, go put it someplace else, okay? It's not just a task list. Now, product backlogs, yes, can contain bugs, some of the things that you need. And now on a really geeky, on an inside baseball sort of thing, Jay, you used the word prioritize. Lots of people use that. I prefer the word order.
Yes.
Okay. Priority tends to talk only about urgency, but order starts to talk about some of the dependencies that you were referencing right there.
Yes.
So getting things in order and looking at that sequencing, especially for those milestones, we got to do this because this milestone coming up is an entirely valid thing to be putting into the backlog as you're looking at work.
That's right. Yep, agree.
Yeah. I thought the point about understanding critical path, from my experience, is also really important, because if you don't know where that is, you can easily get off track and miss weeks to months of schedule if you don't have a critical path understanding that. So
now, in terms of tools, I would just also throw in that if you're dealing with bills of materials, it's important that you put in a process for managing that, so that you keep track of your revisions. So when you update a product, that you've updated your official list of what the components are. and that you've got a place to document that. Very early stage, your notebook or a spreadsheet might be fine, but when you're starting to deal with third parties or manufacturers, having a strict controlled system where parts don't get changed unless the approving engineer actually, signed in blood that that part's supposed to change. That keeps you from buying the wrong things, from having the manufacturer buy the wrong things, from suddenly getting there and say, wait, why do we have this part? And some buyer said, well, that's what I thought we were using. Well, no, I changed it. Well, where was it written down?
Yeah,
So this is really key. Yeah.
Yeah. So that's a great segue to the next question, which is what tools do you see being of value throughout the process? I think, they're talking about things, I believe, like PDM, PLM, ERP, et cetera, to best support the development and then on into commercialization process.
Yeah. Yeah, I think we're just answering that, but I think a PLM tool, that lets you put all of your parts and all of your parts documentation in a change control environment is very important. And then once again, you funnel it at the beginning. Changes are pretty easy to make. Maybe just on the engineer say so, but as you start working with the manufacturer, say on your DBT or PB, EBT, DBT runs, you want to now start to lock these into build, strictly configured builds. So I'm building version, 2.1 here, and it's this exact BOM. And if I decide I need to change it, fine. But you run a change process that keeps a record of what you did and updates the BOM, so that next time, the next build is done with the new design, not some copy of the old design. And managing that, if you can get into a PLM system rather than emailing spreadsheets around, because there's no question, I've had it happen. You email a spreadsheet, but the guy on the other end across the other side of the world used the old spreadsheet and built the wrong thing, right? And you just lost a month, So that kind of tool is important here, in addition to, say, your scheduling and planning tools.
Yeah, and just one quick clarification. I think the question was, is there a tool that exists that encompasses everything in one tool? Not that I'm aware of, but I don't know, Bernie or Jay, if you have any insights on that question. Yeah.
My feeling is there's people who will sell you that, but when you dig in, they probably don't cover everything as well as you want. It usually ends up being a combination in my view.
Yeah. From the hardware space, I'm a little disconnected on the tools these days, so I would not be a good answer. But in my general experience, this is not Mordor. There's not one ring to rule them all, one ring to bind them.
Yeah.
You're probably going to wind up figuring out the right set of tools for your instance. Everything Jay said about the version control, absolutely. But it's going to vary from organization to organization. You might look at, there are some vendors in the Agile software space that really look at the entire tool chain, because different parts of software for SaaS services behave a little bit differently. The creation of software versus the operation of a service like Facebook or Twitter, as an example, are a little bit different between the creation and the operation of things. The same way that
I would just add that my experience developing a good strong process manually before you and then semi-automate and then fully automate is absolutely the way to go before you start just throwing software tools into the mix, right? You gotta have a tool support the process. Process doesn't support
totally agree with that, Mike. And that is a mistake, and that sometimes people buy the tool and don't think about the process. And then I think it's much better if you figure out your process first. Like the old fashioned, we say, well, figure it out on paper first and then put the software tools in. That would be the ideal case. Yes.
And here's a key principle that we haven't touched on about Agile: low fidelity prototypes. So that you can get fast feedback. We've kind of touched on it in terms of soft tooling or breadboarding something in hardware. Or like having extra lights, Jay. So low fidelity prototypes, even like sketches, pencil sketches, or like Jay has talked about, sketching something out for an overall like that. That's a good practice in Agile. Low fidelity prototypes up front.
Yeah,
agree.
We're moving on to the next one. This is from Nigel. what are the top 3 Agile project failure reasons that you have experienced in the Agile NPI implementation process?
Ooh, I've got one.
Go for it.
Okay, so I would honestly say across my experience in Agile, the biggest problem I see is too little discovery. People rush to build something. So I'm going to rhetorically ask this to the audience. Y'all ever hear of the Apple Newton? Yeah, you don't remember the Apple Newton, Mike? It was the world's
Actually,
first.
I do remember it.
Yeah, it was the
Sadly,
world's
I do
first
remember it, yeah.
PDA. It was a bomb. It tanked, probably because Apple didn't do enough product and customer discovery. They built a beautiful product for the time, but there was no demand for it.
Yep.
So, like, one of the big things is not enough discovery, particularly about.
And just to clarify, when you say discovery, you mean market discovery, correct?
Yeah, so
Yeah.
they didn't do enough product. What does the customer want? What is the problem that we're solving for this? They just went out and built a product. They slammed, effectively straight into delivery. I've got another one that I routinely see. Unclear intent is the way that I phrase it. Okay, so that lack of product goals is really prevalent. And Agile talks about both vision, long-term, ever evolving, product goals, long to medium term, but pretty concrete. Think of those as releases on a roadmap. And then sprint goals, what are we doing in this iteration to get us towards that product goal? I find a lot of organizations don't set those product and sprint goals.
Yep.
So that unclear intent is a second thing that I'd say, in addition to lack of discovery.
Yep, I agree with that. I would phrase it as lack of clear product requirements. I mean, in my view, you want to write down a very specific list of hard product requirements. That obviously needs to be negotiated between the people representing the market and the engineers.
Mhm.
And but then when you move forward on that until you find you have to make a change. That doesn't mean you can't change it, but it means that if you say, hey, performance isn't as we expected or something, or cost isn't what we expected, or marketing comes back and says, oh, the market shifted, you sit down again and you renegotiate. So many times I've seen tragedies happen where the engineers are building one thing and the product managers think they're getting something else. Happens a lot. The other area that I see is what I would call failure to make timely decisions. So very often you're going along a project and something is going too slow, that it's not performing as well. And the engineers are going to be like, oh man, yeah, if we just had another week, we could make this work, right? And then a week goes by. If we just had another week, we could make this work. And nobody wants to be the bad guy to say, hey, we're out of time. We have to decide it. And so you kind of can fool, you can rationalize, you can fool yourself. Oh, we'll make it up later on. We'll just get this faster. And what happens is you end up slipping your key decision out 2, 3, 4, 6 weeks, and you'll never make it up. Something else will go wrong down the chain and you'll never make it up. And then you'll be in real trouble down the end.
Done beats perfect. And I think
that's
we're
right.
close to done.
Yeah. No, I used to have somebody with a big sign that said, you want it bad, you get it bad. So that's kind of the way it goes. Anyway, there are a few more questions. I don't know that we have time at this point to answer all of them. We could take So what we would be happy to follow up via email or have a chat after. So why don't we go into the wrap up phase here, and I think we'll thank Bernie and Jay for the time here. We appreciate it, and as well as the audience for attending. If you do have any questions, my email is there as well as Bernie's, and we will be making this the video presentation available on the Product Realization Group website. So if you want to go back and pull pieces out, you're welcome to do that. We'll put an announcement on that. And again, if there were questions that we didn't answer, feel free to reach out, and happy to have an offline discussion about those. So